Okay, example 7.4. Use fzero to determine the roots of log x squared is equal to 7. We're even given a hint. Right? And this is actually a problem that's easy enough to solve by hand pretty quickly, but let's use fzero for practice. Let's do it. We'll be able to compare it to the correct numerical answer. Okay, here I am over in MATLAB, where again I've tried to set things up so I can see the equation we're trying to find the roots of down here. And since I'll be plotting my function with fplot to try and get an estimate of where the root is, I'll keep some blank space over here to put my plot. Okay, so we want to find the root of this expression, so I know that I'll need to set up an error function. Okay, so I'll start with my function signature. Res, so we have a single output, is equal to, maybe call this log error, and I'll have a single input variable, x. Okay. So we want to find values of x for which this equation is satisfied. Okay. And so when we set the problem up to be used with fzero, we need to get it in the context of a problem that could be solved using a bracketing method. And so when we're looking for values of x that satisfy this expression, it's the same as finding values of x such that the expression log x squared minus 7 is equal to 0. Okay. And by setting it up so that we have a function that is equal to 0 when I have a solution, that's going to lend itself to working with the bracketing technique in terms of thinking in terms of intermediate value theorem, where if I'm looking for where it's equal to 0, I know to either side of that solution, the function has to change signs. Okay. Cool. So let's do it. Okay. So res will be equal to the result of, remember natural log is log, so log x squared minus 7. Okay. And we'll play around with this a little bit. So just for completeness, I'll add some documentation. I'll start with my function signature. And I'll add a note that it's an error function to solve the expression log x squared is equal to 7. So we'll save it, and so by default, MATLAB will suggest a name of the file of log error, which agrees with the name in our function signature. Okay, so we'll use fplot to begin to get an estimate of our root locations. Okay, so the command is fplot. Then I need to give it a handle of the function I want to plot, which in this case is log error. And then I need to give it a range. Okay, I have no idea what the range will be, so let's just start and guess because it's, hey, easy enough to plot. Okay, let's just do something wild like 0 to 100. Okay, and I see my function essentially just looks like an exponential function, and we'll come back to that in a second. That crosses my 0 just once, somewhere here around 60. Okay, so I could try and zoom in on this range, or even with this big range, it looks like it crosses just once. Okay. And it looks like it's about 60. Okay, so let me just shrink this a little bit. And let's just turn grid on just to see. Right, so that 0 appears to be not 60, actually here about 25-ish. So to solve for the root, it'll just be fzero at log error, and we can give an initial guess of 20. We could give it a search range of 20 to 40, all the same. Okay, and we get 33.1155. Okay, so now a couple of things with this problem is one, this is easy enough to solve analytically. So log x squared, so log rules, this would be equivalent to 2 log x. Okay, and if you want to check that, I can rewrite this as 2 times log x. All right, and I get the same exact answer. Okay, so log rules, this is 2 log x is equal to 7. So if I were to solve analytically, then x would be equal to the exponential of 7/2. So if I check it, exponential of 7/2, right? Exactly the same value. And there's our exponential growth function that we're just seeing. Okay, cool. The other thing we could do here is just like the last example, we could equivalently solve this using an anonymous function. Okay. So if I close this, and we're essentially restarting just for completeness. Okay. I could create an anonymous function. So let's call this log air, A. Okay. It's going to be of type function handle, the single input variable x. And what I'd like to do within that expression is, exactly that same one line from within our function file. Okay. I want to evaluate. We'll just literally copy and paste here. Okay. So note, when I set up the anonymous function, I say it's the contents of this function file. I don't need res is equal to. By default, right here, it's just going to evaluate the result of this expression, right, and that's what's going to return. Okay, and then it's easy enough, even if I skip the fplot command, just look at fzero, right? Difference being log air A is now of type function handle, so I don't need the at. Update the name, and everything else is exactly the same. Right? So I can readily solve this using an anonymous function just as well, and then my solution is pretty compact.